Hey, Nias. Hey, Nias. How are you?
Hey, doing all right. How are you, Toddy?
Doing good. Do you know somebody, whether Bunny or Pritesh will join, or should we get started? I think James is not feeling well, David said, and actually I see a message from him.
Bunny should be joining. Let me check with Ritesh really quickly.
I can also get started just a little bit. When I look at the agenda, I think that the tough discussion is
Yeah, that's the only thing we have on the agenda today. So,
okay.
yeah.
Um, and I know that a lot of the people on the call have either like read a paper, or I imagine everyone has read a paper or seen a talk on tough that is like a death by PowerPoint talk. Um,
I'm sure I have read one. I don't know about Vani and Nias. Nias, I guess you are familiar with Tough.
Yes, I'm familiar with Tough.
Yeah. And David, I know you are also, right? Yep.
so I thought maybe what I do is try rather than talk about this, the usual way we would talk about it is we'd sort of motivate the problem and then talk about the design of tough. And we do this in a way where it's like not it's more of like, hey, you don't want to use just like GPG signing or something or HTTPS. So here's how tough does things. But I thought that it might be more useful for you all to understand more about why tough does things, not just like what it does, but like what our thinking was behind why we made some choices, and to maybe try to like more compare and contrast might be more interesting than doing just a focus on tough design. Does that make sense?
That works for me. David, Nias.
Sounds good.
Okay, so I'm gonna just try to do most of this by just whiteboard and see how this goes. And please let me know if anything isn't clear. Okay, so first of all, let's say that we have something that we want to sign. So in this case, let's just say it's some kind of package, and you're going to have to forgive my terrible art skills here. We have something we want to sign. Well, there's three different ways we could go about this. Okay, and one of them is to embed the signature inside the package. So let's say that, we have this package and Toddy wants to sign it. Then in some part of this package, there's now a field that has a T in it, right? Another way to do this is we go here, and what we do is rather than embedding inside the package the signature, we have a detached signature that is a separable thing that Toddy writes that says, I want to sign this. Okay? And if we have two packages that are different that Toddy wants to sign, then it's also important here, if this is package A, right, that Toddy's signature here, of course, applies to A. He needs to say which of the packages he's actually signing, because maybe he wants to sign package A, and we have package B here. So Toddy's going to sign package A and package B like this, right? But he's not going to sign some other package over here like package C. So he has these detached signatures. Does that make sense to everybody?
Yeah.
Okay, great. Okay. And the third way of doing this is we have these same packages, A, B, and C here.
Hey, Justin, I don't think we see the whole board where you're drawing though. I don't see the top. Oh, okay.
Sorry, is that better?
Yeah.
Okay. So the other way that we could do it, these are detached signatures that are individual for the package. The other way we could do it is we could have Toddy create a file that says A and B, and then sign it. Okay? All right? Okay. So this is both signatures in one file model. This is effectively what Tough does. This is detached signatures, which is what Debian does, and what Notary notation, I don't know what to call you guys. Let's put Notary down, does. Embedded signatures here, this is what a bunch of things like APKs and RPMs do. Okay? And so let me talk a little bit about kind of the pros and cons of these solutions here, and how they, why we picked this solution, right? And what all the differences are. Okay, so in this case, there's a real problem here. So let's say that I also think that this particular package is good and useful, and I want to sign it. Well, there's a problem because Toddy's signature is already here. And there's usually only room for one signature in here. So that would mean I probably have to make an entire another copy of this package in order to sign it, which is bad. Okay. So in this case here with the detached signatures, I can go, and one of the nice advantages that Debian's detached signatures, Notary, other things have is if I want to go and sign these, I can go and make my own signatures here. And let's say I only want to sign A, I can just sign this other file for A. Does that make sense? And in the Tough model, of course, I can also do this. I can go here, and I can also create a file that only has A and is signed by me. And so the disadvantage here is in this embedded signature case, you can't have multiple signatures, or at least that becomes difficult to manage. The advantage of having this is that they're inseparable. Usually you don't extract a signature from something or do something. Whenever you send this thing along, it always comes with a signature. And if you don't have that property, then you have to worry about situations where, let's say you transfer the package first, and then you're going to transfer the signature, but then you have a network outage, or you have something else happen, right? And so your registry has to worry about those kinds of problems and attacks. Or if you transfer the signature first, if I transfer this first, I have to worry about all the problems that come with having a signature but not having the artifact, right? And it's not that these are problematic in that the world will end or something will fall apart. But what usually ends up happening in these kinds of systems is you have a problem where you have one or the other, and to users, this is you want to be careful that your users don't get used to seeing like a package without a signature or a signature without a package, because those are the types of things that an attacker who controls your repository, like your registry where you keep all this stuff, would likely want to do as part of an attack, right? And so that's actually why it matters more. You're not that worried about a momentary hiccup. You're worried about the fact that you have to put logic into client machines to deal with this case, and that the logical things that people will do will be to mask security errors that are like security issues that could be occurring due to a malicious attacker. Okay, so are we, everybody okay so far? Anybody want to ask anything? Just jump in if you want to ask a question at any point. Okay, see lots of thumbs up. Thank you. Okay, so now there's a question. I think, there's a very compelling reason why you want to be on this side, because you want to be able to have multiple signatures and multiple people be able to say things. Okay, now there's a question about why do we care about the tough model versus the notary model? Why does this matter? And one of the problems, the biggest problem here, comes with the fact that if I take over this repository, I can get rid of this. I can take this off. And this is now gone, but this is not. So I can control which of Toddy's signatures, these are all valid signatures, I can control which of his signatures are seen and which ones are not in a pretty easy way. Okay. And this doesn't seem at first like it would be a big problem, but can become a big problem for reasons I'm going to end up talking about in a moment. Okay. Whereas here in the tough model, you can't just take Toddy's signature only for A or only for B. You'd have to remove all of Toddy's information here. Okay. So one of the big problems you have when you start to think about an attacker who goes and breaks in and wants to manipulate these signatures is, how do I make signatures and things like this expire or be invalidated or go away over time? And this is absolutely critical, right? The fact that you thought something was good yesterday does not mean that it is good today, right? And you need a reliable way in the face of an attacker to be able to deal with those. Super important, okay? So this is part of the, like a big part of the reason why Tough works the way it does. So in Notary, when you go and you put your signatures are these separable things that might have timeouts, might live for certain periods of time. You might have some extra server you go to get information about what's revoked or other things like this, right? And you have a bunch of problems with going to this extra server to ask these questions, because if the server is down, what do you do? If you punt that to the user, then that was part of the security thing I disclosed that's historically been deprecated from browsers and things like this, because that behavior model of doing that has been shown that it doesn't provide very good security. It puts the user in a position where they don't have the information they need to make the right choice, okay? And so instead what you'd want is you'd effectively want to know that information wasn't removed by anybody other than, if Toddy wants to change his mind about this and say A is no longer valid, Toddy can go and make a new file that says like, not A, but as B, A is not on here, and then Toddy, and then he wants this to be effectively overwriting his old file on here. Okay. And so there's a couple of potential problems you probably see here. So one of which is, well, if I'm this evil repository, why can't I just give this old file that Toddy said everything was fine? That would cause all kinds of problems. Like, you know, couldn't I just replace them, right? And so, you know, and so what Tough does is Tough has this role called a snapshot role. Okay. And in the snapshot role, what happens is that we take all these pieces of metadata from that are created by, you know, the different people who are going and adding their things in, and we number them. So Toddy, when he's created this, he said, oh yeah, this is the first piece of metadata I'm writing, and this is piece number 2, right? And so if someone's already is downloaded piece number 2 and you try to send them piece number 1, of course, they will realize that you're sending them something old, right? And they won't accept it. Now, if Toddy changes his mind and wants to support A and B again and say they're both good, he can do that. And the way he does that is he just creates a new thing that says A and B and has a number 3, right? And he just keeps incrementing this over time, if this makes sense. And this provides Toddy a way to revoke things and do things as long as people are somehow able to get the latest version or know what the latest version is. Okay. And so what Snapshot does is it delivers metadata that tells you for all of the people on the repo effectively what the latest version number of their signed information is. So for Toddy, in this case, it would be 3. For me, this is maybe my 5th one that I've done. So this is effectively what the snapshot like role inside of Tough is doing, if this makes sense. And then because of this, you know, even if I haven't downloaded Toddy's file before, then I can always know that the version number I must see here must be 3 or greater from the repository. So if the repository tries to send me version number 2, because, you know, they want me to trust this thing, or they want me to trust something that I shouldn't trust anymore that Toddy used to think was good, then I can go and I can like realize that I'm being attacked and reject it. And the nice thing about this is that you also never have a situation where, you know, this is all in the same metadata on the same system. So you don't have to worry about like some extra server doing revocation of things or timing out the statements in these files. Toddy writes this once, and this lives like until he changes it, right? And so there's no need for Toddy to constantly reassign this or do other things. Where if in here you're going and you're putting like, you know, a 1-day timer on these, or you're putting a, you know, like have a separate server that provides a whole bunch of other problems, which is why we went with this sort of model and this sort of design. Now, the plus side of this model is that if you want to take like one of these artifacts and move it to a new registry, you just copy these 2 files over and do this. And anybody can do this. In our case, if we want to move just one of these artifacts over, there's actually a way to do that. You can copy the whole file over, but someone needs to create something that says that like effectively A is the only file that exists on this other registry, right? And if Toddy creates that, it's very straightforward about how that works. If you want the registry itself to create it, you can have that happen too. But someone needs to make that statement inside of Tough to do it. And so you actually end up, you know, the better part about Notary here is that here you move 2 files, and you're done. In Tough, you have to move 3 files. You have to create a file and move the 2 over in order to move something from one registry to another. I'm going to pause here because I just covered a whole bunch of stuff, and I'm sure somebody has a question or a comment or criticism or clarification or something.
I'm fine with everything what you're explaining. Just think that, yeah, Pritesh, Vani, David, Nias.
In the partial copy case, how do you establish that the third party can create a trusted representation of what Toddy has done?
Okay, great. That's a perfect question here. So there's a concept I haven't talked about yet for Tough. That's another key difference as I understand it from notary notation, but I also don't fully understand all the aspects of what was there. I wasn't, paying attention years ago when you all were discussing things. And I don't think this was in at this point, but may have been added now. So there's a notion in Tough of a delegation. And really what a delegation is it's a way for someone to make a statement. Like I can make a statement and I can say that, basically I can say trust Toddy for anything that is NOTA star package. Because I don't know if you're going to produce notation or notary packages. I can just say, trust him as though, for any of these sorts of things. And by the way, this just ends up as a statement inside of the same file here that I upload and sign, right? By doing this, so first of all, if Toddy's the one who's going to move things over to the new, but let me back all of this up just a moment and say, there was a reason why you knew to trust Toddy or me in this original case here, right? On this original repo, okay? And so if you have that same reason for that foundation of trust in the other repo, then Toddy can make a statement that says, trust only my statement about A for here. You can also go and just have him sign a new file that only has A in it. Or you can go and say that 2 people actually need to sign off to say whether things here are valid. Toddy's one of them, and the other one is a role that the repository has to say which packages were copied over, right? Because Tough has a notion called thresholding. So you can actually say, if both Toddy and the repo say that Toddy should know about a file, then trust this, right? And I know all of this sounds like complicated to say abstractly, but this gets hidden from users. Nobody ever sees this or writes this. It's just like a little bit of the code that goes in your file here, if this makes sense. It's a little bit of it's a statement in a file. So it's often the kind of thing that explaining it to users is hard, but just having their tool do the thing is super, they don't know it exists. Does this make sense?
Yeah, and does Tough define the policy language that's used there, or is it flexible on the?
So Tough has a notion of delegations. It has a notion of sort of directly doing these detached signatures, which is how it refers to targets. It has notions of thresholds. It has notions of other modifications to the to the way in which you would do a normal vanilla delegation, right? But it isn't like an OPA style language. There's no programming language. You can think of it like more like a sort of firewall allow deny list is a way to think about it, but it has this like these delegation and thresholding primitives and stuff built in. It's not a general purpose like language kind of thing. And that's all built into the tough specification and in the implementations and stuff like this. So one of the kind of interesting things is that just by supporting like thresholds, being able to say ands of ands and ors of sets of users, delegations, can support like an enormous range of things and be able to reason very concretely about the security you get. So, yeah. So who else, anybody else want to ask a question?
Yeah, I have one question around snapshot. So is it like when a user comes up, it downloads the snapshot for first time and then keeps on pulling the snapshot?
Okay, so in general, you keep refreshing your snapshot information. And so in practice, if you have a small repo, as is moderately common, you can just download this file every time. If you have a larger repo, then there are things you can do where you can download like a Merkle hash of some of the information in there that gives you basically the same thing. And there's also a cryptographic primitive called an RSA accumulator you can use where you download something very, very small. And it lets you know this property without actually having to download anything large. They're extremely small and they scale, it scales very, very, very well. I can give you more information about this, but it's like, it's tiny, absolutely tiny in comparison. Even for things the size of like Docker Hub and stuff like this, it's very, very small.
Okay. Also, like usually in container world, like container keeps on coming up and they refresh frequently. So if it's a new container coming up, it will get the fresh copy of a snapshot. And the first time it's
great question.
How will it trust it?
Oh, sorry, go ahead. I mean,
It's like, so at the first time, like let's say a new container comes up, at the first time it requests for snapshot, and let's say registry is taken over and it returns an old snapshot, so it will still trust the old snapshot?
No, so usually what you would do is when you make your container image, you put keys in it, right? Because you need to have some keys and configuration and stuff like this for to, for instance, tell it like what registry to go to and what keys to use to connect with the registry. So usually when you do that, if it's something like containers where you're just constantly throwing them away and doing new ones, you would put like the RSA accumulator or the Merkle tree, or if you have a smaller repo that isn't the size of something like Docker Hub, you can just put an older snapshot file in. And then when it starts up, it'll download the diff for that or download what it needs. But the advantage of putting an older file in is, let's say that these numbers are no longer valid, that now Toddy has it, today he did release 6, but I'm still on number 5 or something like that. If an attacker takes over the repo and you have this old file with 3 and 5 in there, they're not going to be able to go and replay things that are older than 3 and 5 versions of our metadata. They would be able, if they took it over and control it, they would be able to replay version 4 or 5 for Toddy, which could be really, really bad. But at least they can't go back and replay much older things. So like
so you're suggesting, sorry to interrupt you. So you're suggesting bake the snapshot.json inside the image itself so that it's available every time you download the image, and it becomes a baseline for new pulls.
Yeah, it becomes a baseline for how far back an attacker could possibly roll you if they
makes sense.
If they control it. Yeah, if they control the repo and can write a new snapshot.
That makes sense. Yeah.
Yeah, but Yeah, and I know this is like more complicated and more of a mess than what happens in Notary notation, but by doing this, we get to avoid the whole like key revocation as a separate service and a lot of the other things like that, like timing out metadata and rewriting things and stuff like that, which is why we thought and think that this is probably the better approach overall. But I'm not, there are pros and cons. So
Makes sense. Yeah. I don't have any more questions.
So, Justin, because previously when we discussed those things, so one of the things is first, one important thing for us is really this portability between registries, what David actually asked initially. And that is one thing that actually it will be interesting to understand in more details how that can really work, especially with OPI registries, that they don't have this, for example, additional information that you store. So one of the benefits that actually you gave for, let's say, TUF is that you can go to the same endpoint, right? But OCI does not specify, for example, anything else on the OCI v2 endpoint that does signatures or stores metadata or does snapshots. And most of the registries that are available, they do not have such services available. So that's kind of this is one of the things. The second is
hold on. We talk about that one first because I will forget the first one otherwise.
Go ahead. Yeah, go ahead.
So if you, Toddy, are the person moving the thing over and you have your signature, then there's no problem at all in TUF and it's super seamless because you can either re-sign it, you can just re-sign it if you want, or just do the delegation thing and you're done. Like it's that easy. If you're letting other people do this and move things around, then we do sort of have the presumption that you have some reason to think that they're like some basis for trusting the person to pick out the things you signed to have them be on the repo. So you sort of have to form that like a very minor trust relationship. They don't get to say this is valid, but they will get to say of the things Toddy says are valid, these are the ones that you should use, right? And yes, you have to do this like threshold thing to do that, but in some sense that's almost by design, because the reason why we're putting these in a single file and attaching them together is to make it so people can't separately pull stuff apart without being trusted in some way. So in your model, is it more that a user the party who's doing the signing is the one who's going to want to pull the file over, or is there some like external party who's doing it that isn't trusted, or how does that work?
It is external parties, because let's say if you think of how the containers work, right? So I really publish a container, I push it on Docker Hub, I sign it with whatever signing technology I would like. But I do not know who's gonna pull that container. And normally what happens is they not only pull it, but they also move it into their own registry, and they want to do something else from there, right? And this container can travel through a couple of hops. Like you have let's say, take the Docker Hub, for example, is my source. Then I can copy this into another registry inside my organization. Then I can take this into a third registry inside my organization, and then I can move it into an air gap, for example, environment. Right. So this is the scenario that we are kind of, at least from our point of view, are looking to enable. And it would be interesting to understand, okay, who needs to resign, who needs to, and the other thing is that we've heard feedback from customers. So once let's say if I copy from Docker Hub to the first registry inside my organization, it is fine to resign. But after that, customers, they do not go and re-sign every time when they do a copy. So that's the feedback that we got from customers.
Yeah, I get that. And we actually have a lot of, this isn't that different. There are a lot of people who use Tough for like IoT environments and other stuff like that. And when they use it for those types of environments, they do a lot of this like copying and putting stuff on flash drives and other stuff like this. In general, you can do this one of a couple of ways. So if you, and it's sort of up to you all, like up to the adopters to decide how to do it. It's not like, we don't force you to pick a certain model. Just like I told you, Toddy could re-sign it, or there could be a threshold here, there could be whatever. One of the kind of good and bad things about Tough is trying to be secure, but not super opinionated. It's not trying to force you into a certain model. So the copying thing is no problem for Tough. Whether you re-sign or not when it first goes into your organization is not particularly a big deal. If you want to re-sign, you can, and then your trust relationship you have for your targets metadata on this initial node is going to be to that new key. Okay. If you don't want to re-sign it, then what you do is you delegate trust to Toddy or to whoever the people who you're pulling things from, right? And there's pros and cons to both. Like we see in the automotive space that most of the OEMs really only feel comfortable re-signing everything. But in some other contexts, we find that people want to say things like, well, you should trust us, but only if both we and the original party who signed it both say it's okay. Like we want a threshold, right? And some people, so you have, I've seen definitely both models where it's, I trust whatever Toddy says, Toddy and I both have to agree, or I'm getting rid of Toddy's signature and signing myself. All of those models are just like very slightly different setups for your Tough metadata. And that is true even as it goes from place to place to place in an org.
Yep, that makes sense. The second one is you're giving the example with the two packages like A and B, right? And you create a single file, and I start actually incrementing the version of this file that contains the signatures, what I sign.
Yes.
You already talk about like, okay, if I'm a, let's say, consumer of these packages, I don't want to take the package B. I can take A only, and I can do a re-sign based on the.
Sure.
Now, the question is, single repository can have multiple publishers. Like Docker Hub has a bunch of companies that publish there, right? Do I, as for example, publisher, I create only the metadata and the snapshot for the things that I publish, or do I need to go and actually create a snapshot of the whole registry? Is it per repository? Is it and can I create snapshots by, let's say, lineage? So we have this concept of lineage, and you can think of lineage like, okay, I have Python 3.10 is one lineage of images, and Python 3.11 is the second one. Python 3.12 is third one.
Okay, so to translate that all into Tough terms, usually what you end up doing is you have one snapshot across the whole repo. But in the way you're talking about lineages, because presumably most things are not going to cross lineages. They stay within a lineage. So in Tough terms, you would just create separate repositories for those, right? And they would each have their own snapshot file. And so this is why, like for Docker Hub or for other things like that, you have, many, 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 many things you need a snapshot file over. But the good news is that with these RSA accumulators, the Merkle hash digests and other stuff like this, it's actually still really efficient, right? And so all that people get is they get this like, little piece of cryptographic metadata, and it gives them all these same properties of knowing that version numbers aren't going backwards and things like that. Yeah, I think from our standpoint, we think like lineages would be separate repos. If you have things that cross between them, or you have people that, by the way, there's no reason why a single developer can't like sign files for different lineages and stuff like that. You could set that up in different ways. You have a lot of flexibility about how you actually configure those types of things. And by the way, this is also very similar to how things work in a lot of automotive and Internet of Things contexts, where people will have effectively things that are only supposed to be able to be installed on certain types of automotive computers called ECUs. And you can put all of those restrictions in to like in a part of the tough metadata, and things will get checked against that. So there's a bunch of like, that's like a whole nother hour-long community meeting to talk through all that stuff, but it exists.
It's actually an interesting topic. I looked at some of your papers and read that, but Pritesh, do you have a question?
Yeah, I mean, who maintains this snapshot.json in this use case? Is it the registry who has to maintain it, or
yes?
Because now the registry is the one who is giving the overall view of, let's say, GitHub repo, Docker Hub or any other repo. So it's we are transferring the responsibility to maintain snap.json to registries.
Yes, but snapshot is not a very trusted role. If you control snapshot, you can possibly, at worst, rewind a version number by a small amount, by the amount since the person last visited. So one of the other like tough concepts that we talk a lot about in talks, but I think is sometimes hard for people to like grok right away, is tough is designed to have to compromise resilience. It's a graceful degradation of security as attackers get more and more access. So we assume that at some point, someone will break into your repo. It will break into your registry and will gain access to it, because it's happened before in lots of cases, right? Lots of high-profile companies and organizations. And so our security doesn't just fail and all your users are screwed if this happens. It just means that you have this like tiny window of potential rollbacks that the attacker could do a few potentially bad things to probably, and have to have some intelligence about how they launch an attack. Yes, but the repository/registry has to maintain a snapshot, and also maintains a file called timestamp, where timestamp is effectively kind of a mirror and other like CDN friendly way to make sure that the snapshot itself isn't stale.
Makes sense.
So yeah.
But so unless everyone has a base copy of snapshot, or at least a base version of a snapshot, they are relying on registry for correctness of the data, or basically that you're getting the fresh or latest copy of an image.
You're relying that the metadata here from Toddy and me wasn't replayed by an older version, but
Yes.
It doesn't. So if someone starts up and has absolutely nothing, has no basis for trust, first of all, they have to have somebody to know they're talking to the right repo and establish trust with it, right?
Yeah.
And so in practice, tough adopters will basically always ship the root tough keys along with the image that they send, right? And if you're shipping the root tough keys, they'll also just put the snapshot in of when they made the image. So you can do trust on first use. That's actually how I think Notary V1 used to do it, was just not have snapshot, but have root. But the common practice for most of our adopters is you put some version of snapshot in, and that gives you much better protection.
Okay.
But when you say ship with the image, I mean, you're really talking about shipping it with the client, right?
You're shipping it with whatever's doing the verification as
Right.
you're doing the install. Yeah. And it doesn't have to be super up to date, but you don't have to like redo this snapshot every week or something like that. But it's just, it just gives you some bounding on this replay, which by the way is completely unbounded if you don't have this. Like you could just replay stuff arbitrarily from like normal detached signatures.
That makes sense. So also I have one last question. There's a root, there's timestamp role, there's snapshot role, and there is target role, right? That's 4.1
Yeah.
at high level. So we are saying we'll have one root for a registry like Docker Hub. The snapshot would be controlled by registry, timestamp would be controlled by registry, but target would be individual user.
So usually the way, so we talked about delegations here for a minute. And the models here will work different for different registries, by the way.
Okay.
But one thing, the sort of vanilla tough in the very early papers was imagining more of a model like you have with PyPI or Ruby gems. And in that model, the way it works is that, like, I know, like PyPI has some top level targets, and they know that the Notary project is managed by some developers, including Toddy. And so they would delegate to his key for this and delegate to my key for like tough, right? And then off of this, we would do other delegations and sign other files. But this relies on this top level, which comes from the repo, to know who all the projects are. And by the way, the reason why, because the repo then serves as this foundation for targets level trust. Okay. But in a case like you have with Docker Hub or other registries, you don't really want a compromise of this repo to cause you problems. You'd ideally like it so even if the repo is compromised, you're not trusting this top level to do this separation out. So what Tufts supports is it supports you going and effectively saying in your metadata for the client that my top level really should start here at some specific role that you pick in the repo, right? And then this becomes your top level role that you pick. And so like if NYU and Microsoft and AWS, Amazon all want to have separate top level roles and use the same repository, the same registry, they can do that no problem. And even if that's compromised, even if the root role is compromised, that can't be replaced. So all that a compromise does in that case is basically the same as the snapshot and lets them rotate snapshot and timestamp keys and stuff like that.
But still, I think the root defines those roles, right? For example, for each identity, root defines the role. And yes, you can trust that for individual role, but I can replace the role to say, okay, so you're saying anchor on the individual role instead of root?
So imagine that. So if you look at the root.json metadata file, right?
Mm-hmm.
It has targets, it has snapshot, timestamp in it, right?
Yep.
All right. So what this does, what I just described, is it tells you ignore the targets file.
Sorry to interrupt you. We cannot see the screen. Can you rotate?
Sorry. Yeah. So it says ignore the targets information that's listed here. Don't use that top level targets. Use the thing I'm telling you to use instead. This is what it effectively pins the top level targets to be whatever your client wants it to be. So Microsoft can pin it to be some Microsoft based thing. NYU could pin it to be some whatever thing. Like maybe we don't care. Maybe we're okay with the top level, so we don't pin it to anything. And Amazon could pin it to be some Amazon based thing. And we can all share the same repo. And even if this root file is compromised, no matter what they say here, we just ignore it. You all just ignore it. I'm in trouble because I'm at NYU, and we just leave the top level targets in control of the repository. But you all would be safe from that kind of attack.
Got you. Yeah. I think I'll take some time to digest that, but yeah, I will read more offline.
There's a lot here to digest. So yeah.
Any other questions, David, Bunny, Nias? So just in the maybe remaining 5 minutes, and actually that's very helpful information. Talking about the kind of the root of trust and how do you actually expect this to be delivered with the client? One of the concerns that we had in the past is, so unless you have all these things embedded in the client, right, you need to rely on the consumer of those images to go and say what they trust on, right, which is what we have right now in notation as trust policy, right? So in notation, we have this concept of trust policy where when I configure notation, let's say for my registry, I can go and say I trust those things, and from here on, actually start trusting.
Yep.
Are you saying that we need to deliver this as part of the client, or is it okay if we go and use our trust policy as it is implemented right now in notation?
I don't know enough about your implementation to comment on that. I'd have to kind of look in more detail. But I'd say from our standpoint, with any of these systems, you always ship with some root of trust. No one just connects to the internet blindly with no root CA certificates and no nothing and just says, like, whoever speaks to me first, good luck. I guess maybe that's what TFTP is, but you shouldn't use that to boot.
Yeah.
So ignoring things like that, in general, what people do is you have something that serves as your set of initially trusted keys and your initial trust foundation. And in Tough, that's almost always, that's basically always the root, some version of the root metadata. And in cases where you want to override the targets or do something like that, you would include information like that along with it. And you might also include like a snapshot for when you're making this. That is like typical initial metadata for to start with Tough. If you're asking the user to configure things, then there's also a question of like, how do they know things? Like the user is not going to type in cryptographic keys. They might type in URLs or other stuff, but that's still based on some, either built-in CA system root of trust that they have in place or something like it. So effectively, it's the same as what you have with Tough. It's just that rather than most of the people who use Tough don't say, let me use my CA root of trust in my system first to go out and get the Tough root of trust. They just ship that file, which is quite small, along with their Tough client, if that makes sense.
Okay, that makes sense, yes. Mm-hmm.
But it ultimately is, Tough all the way down, right? Because that Tough client that you're shipping that's doing the validation for when you're downloading these things, you also need to make sure that that's distributed and updated in a secure way. So you need Tough around that and so on. And so, establishing the root of trust is the real trick here.
Yeah. Isn't it the same for any software updater though?
Exactly.
You always need a way to update it.
Mm-hmm.
Yeah. I'm not. I didn't say that as a disparagement to Tough, but just as a reality that the supply chain is a chain, and you sort of need each link to be secure, and establishing choosing where you're going to begin that trust is kind of key in all of this.
Yeah, it sounds like you're trying to ask me to come back to talk about in toto sometime, to be honest. But yeah,
that's
I get
one of the
next
topics we would like to hear about. Right? So, yep.
Yeah. Okay. It's I will be happy to find a time to talk to you all about that at some other point if you like. But I'm also happy to answer more questions about any of this. Vani, did you have a question? I noticed you unmuted for a moment. a while ago.
Yes, Destin. I had the question about how and where we define the top level not to be trusted. And I think you answered some of it with Pritesh, like how do you define it, you know?
Yep.
And when do you know that it is not trusted, right? So there is a first state,
Yeah.
and that is when you know it is not trusted. So what is the time and who defines it?
Okay, so basically on your client, you just pop in a file that says like, I am pinning my targets file to be this. My top level targets file is now this. And you know, it's this is what it's pinned to, and that's it. That configuration says, oh, now Toddy is going to be my top level targets here, or you know, Niaz or whomever is going to be my top level. That's exactly how it works, and it's whenever that like is set, then you're done. What it happens in practice is almost always this is preset. Because you just don't ask every developer to just configure their own Notary client setup. I wouldn't expect, at least. In general, with Tough, usually you're just downloading something from your org that's been set up in a good way, and that's already been configured in, and so you had it from day one.
Okay. Yeah, thank you.
Sorry, folks, we're running out of time, but Justin, I would like to thank you for actually this great explanation. Any thoughts, final thoughts, David, Niaz, Pritesh, Vani?
Thank you,
Yeah.
Justin.
No, it's been terrific. Feel free to reach out with any other questions or things like that. I'm always happy to talk about this. So
we certainly will do.
Thank you.
all right.
Justin, just we have to do more reading after this section. Yeah.
Sure.
Thank you, Justin.
Thank you.
Have a nice day, everyone. Enjoy.